Hello, everyone. Welcome to this webinar on Oklahoma drought conditions. My name is Joel Lisenby. I'm the Regional Drought Early Warning System Coordinator for the Southern Plains region at NIDIS. NIDIS is an acronym that we all throw around. NIDIS is an acronym for the National Integrated Drought Information System. We sit within NOAA. I'm also at the Cooperative Institute for Research and Environmental Sciences at the University of Colorado. If you're not familiar with NIDIS, feel free to check us out at drought.gov and you can read about us there. There's a whole lot of other really good resources at drought.gov. I would encourage you to go and check that out too. Before we get started, I would like to go through just a few quick webinar logistics. Thank you for joining us today, and we're using GoToWebinar. For this webinar, everyone is muted. This webinar is being recorded, and the recording will be made available both at the NIDIS YouTube channel and also posted at drought.gov. I'll send around an email. If you've registered for this, you'll get an email with the link to the recordings. That'll probably come through either later today or tomorrow. For today's, the format for today's webinar is that we're going to have two expert presenters, first Gary McManus and then Victor Murphy, who I'm going to introduce in more detail in just a minute. And then following both of their talks, we'll have a section for questions and discussions afterward. And we plan to wrap up all of this toward the end of this hour. So with that, I am quite honored to be able to introduce our two speakers today. First, Gary McManus. Gary joined Oklahoma Climatological Survey in May 1999 and currently serves as the state climatologist for Oklahoma. Gary's tasks are focused on providing citizens and decision makers of Oklahoma with vital and timely climate and weather information, as well as assessing the past weather conditions for the state. A huge thank you for joining us today, Gary. We look forward to your talk. Immediately following Gary, we'll hear from Victor Murphy. Victor is the Climate Services Program Manager for the National Weather Service Southern Region. Actually, I hope I'm not messing this up. I'm reading it, and so you're probably seeing like the teleprompter look as I'm going through this. So he's the Climate Services Program Manager for the National Weather Service Southern Region, which includes the state of Oklahoma. He routinely participates in drought monitoring and the issuance of climate products from various National Weather Service weather forecast offices across Oklahoma. So thank you both for joining us. We look forward to hearing your talk. With that, I'm going to pass the presenter permissions over to you, Gary, and then you can take it away.
Okay, thank you, Joel. It's a pleasure to be here. I wish we were under better circumstances. In some cases we are, some cases we aren't. And I appreciate you calling me an expert. Unfortunately, I've become much too much of an expert over the last decade or so. Of course, we had the big drought of 2010 through 15, and then a series of smaller droughts. This one is, as of now, a smaller drought. It's much smaller in duration, but not intensity, unfortunately. But as one thing that we all know in the drought community, the one way to relieve drought is to schedule drought talks. So that's what we've sort of done over parts of the state here in Oklahoma. So since we scheduled today's webinar back in mid-April, we've had from 8 to over 10 inches of rain over much of the east central part of the state over into central Oklahoma, and a good amount here and there. And then since I tried to finalize my talk last night with the latest data, of course, we had from 1 to 2 inches of rain down in far southwest Oklahoma, which is where they need it the most. So if we have to spoil my drought talk in order to get rain, I say we schedule a drought talk every week. So that's one way to get drought relief. But unfortunately, still way too much of the state is in drought. So we're going to start off with how did we get here? Now this is the drought map from May 3rd. Now we're going to see, and let me just start off by saying we're going to see a lot of improvement in the drought map that we see tomorrow. I can't show you that. It's embargoed until tomorrow, of course, because then you would all go out and corner the commodity market. That's what we worry about. So, but we will see a lot of that drought across the eastern half of the state, and even over into southwest Oklahoma start to disappear a little bit. So keep that in mind. But at least as of last week, we had about 65% of the state in some form of drought, and up to 40% of that was considered the worst two categories of drought, that extreme to exceptional drought. So how did we get here? Well, in the short term, even though the eastern half, as I said, if we look over the last 30 days, we saw real relief. Even down, as I said, that little finger of 6 to 7 inches of rain down in the far southwest Oklahoma. But you can see much of those reds and oranges yellows, that's where we got the decent rainfalls over the last 30 days. If you look at the percent of normal over the last 30 days, however, you can see much of the state across western Oklahoma did not get that relief. Now, some of this also in southwest Oklahoma will improve just a little bit when the new map comes out tomorrow, the new percent of normal map. But again, much of the northwestern third of the state and the southwestern part of the state still with those really big deficits over the last 30 days. Now, we talk about the long-term conditions that have gotten us where we are now. Those deficits, of course, go back to the end of last summer. You can really trace it back to right around August 21st was the last good rain a lot of the state had in the fall and the winter months. So that's when the drought really began. But we do have some antecedent conditions going all the way back to a year ago, where we see some of those deficits in the 50 to 60 to 75% of normal range. And these are the areas, as we look at like the northwestern third of the state and down in south central Oklahoma, those are the areas you can sort of think of as being more primed to return to drought a little bit quicker if the rains go away again. So when you look at those longer term deficits and you look at that this upper figure, if you look at this region, of course, this is a region that could go back to even a more intense drought much more quickly. But if you look over here in south central Oklahoma, this is a place to watch if we do start to run out of the rainy pattern again. So just a heads up there. But again, deficits, regardless of the recent rains, if you go back to the start of the water year, October 1st, we see those deficits encompass much of the western half of the state. Again, so just those antecedent conditions show we could go back pretty quickly. Poor Kenton, Oklahoma, out here in the far western panhandle, they haven't seen a good rain since August 27th, and that was about a half inch of rain. So, you know, if you go 256 days, you can add today, of course, 257 days without a good rain, at least a quarter inch in a single day, you're really in the dire straits as far as moisture goes. And Goodwell over here at 212 days isn't much better. Now, some of these areas out here across western Oklahoma just barely beat the threshold to get a quarter inch of rain. I know there are a couple of stations out here that got like 0.27 inches, so they fell off the map. But they're still in the same dire straits that they were before, though. So, but those long-term conditions, however, do still spell pretty horrible drought impacts across much of the western part of the state. There's something weird that happened with this drought. A drought intensification, when did it really start to ramp up? And it's an unlikely suspect. We don't really think of it as a winter month to get rapid drought intensification because it's normally cool. It's a drier part of the time, part of the year anyway, so it's hard to get those big deficits. But December 2021 was when our drought really took off. We saw a 56% increase in severe extreme drought, so the D2 to D3 drought from the end of November to the beginning of January. Very unusual, but that was, of course, fueled by a very unusually warm and dry December. So it was the warmest December on record by over 5 degrees, 5.2 degrees to be exact. Never seen anything like that for any month to have that much of a separation between the first and second ranked months as far as temperature goes. So December was on the far, far extreme of the extreme months. And it was, of course, the 30th driest as well. Some places across the northwestern half of the state saw no rainfall. Now, we did improve the statewide statistics by some of the above normal rainfall across far eastern Oklahoma. But again, an extreme month for Oklahoma, an extreme month in the winter for drought intensification. So just an oddity there. But we do have December to thank for a lot of our current drought lows. The reservoir levels are not too bad right now. We do have some of the lakes that are used for human consumption a little bit below normal. So Stanley Draper's 8 feet below normal. Of course, Lugert, Altus, 25 feet below normal, but that's used for cotton irrigation. But some of these lakes down here in far southwest Oklahoma are a little bit below normal. Of course, with all the big rains lately, the ones across the eastern parts of the state are looking pretty good right now. So it looks good right now. The one cautionary tale I will tell you about is this is about what it looked like at this time in 2011. And, you know, the lakes looked pretty good through 2011. We got into the 2012, 2013, especially that 2013, 2014 time period. Those lakes were, of course, in emergency territory, a lot of them. So always remember, we look good right now. We would like to see those across west Oklahoma look a little bit better, though. Soil moisture, again, from the mesonet here, mostly looking good. The obvious areas of bad soil moisture conditions would be the western panhandle, the western half, and southwest Oklahoma. So we go down to the 16-inch percent plant available water from the mesonet. We do see those areas start to stand out. Woodward standing out. Same for the 32-inch plant available water. So for the column of the soil moisture down to 16 and 32 inches, those dry areas are showing up pretty well. We do see much of the western 2/3 or the eastern, really the southeastern half of the state up into parts of north central Oklahoma looking pretty good with those recent rains. If we go to the topsoil, the topsoils are drier than average. This is from the USDA. So the week ending May 8th, some of this might improve with the recent rains after May 8th, but we do see 52% of the state in short or very short conditions. That's considered by the USDA. That's folks in the FSA going out and kicking the dirt around, seeing how it flies. And normally at this time of the year, at the 10-year mean, that would be about 33% of the state. So we are above normal for this time of the year. And of course, some of that 10-year mean includes those droughts of the 2010 or the 2011, 12, 13, 14, 15 period. So for us to be above normal for this time of the year is certainly not good. But you can also see some of our neighbors are even worse off than us. Texas is 81. New Mexico is probably the drought epicenter right now at 90%. They're having all those horrible wildfires, really bad conditions in New Mexico. So it's bad here, but of course, that's sort of the western part of the state, sort of a part of that big southwestern U.S. drought that's going on right now. It's really up and down this region right here. So how did we get here? Let's go a little bit behind the scenes, look at a few things you might not be thinking about. So as I said, this week's map will be greatly improved, but if you think of that D4 exceptional drought, those dark colors, that's a 1 in 50 to 1 in a year event, according to the Drought Monitor folks. So it's really not supposed to happen that often. It's really, again, that's the extreme of the extreme droughts. Exceptional is kind of a weird way to name it, but I get the point. Again, a 1 in 50 to 100 year event. But if we look at the time series for the statewide drought across Oklahoma, this goes back to the 2000 period, the beginning of the Drought Monitor. So this just goes back the last 22 years or so. We do see those D4 droughts showing up a little bit more often than once every 50 to 100 years. So while it might be the extreme of the extremes, it might be expected return period of once or twice every 100 years. It's been happening more than that. So we can see that horrible period from 2011 through 2015 when it got obliterated by the floods of 2015. And then we see that drought a little bit in 2017 up into 2018. And then, of course, our current drought, that's the periods, and we see that 2006 drought, a little bit in 2008. So those droughts do happen, these smaller droughts, and then the big drought. But the D4 drought does come around a little bit more often than we expect. And changes are occurring. It's getting warmer and drier. If we look at the differences in the normals from the 1991 to 2020 period put out by NCEI versus the 1981 through 2010 period, So basically, we've gotten rid of the wet and cool 1980s, and we've added that warm and dry 2000 teens. We do see that over that difference in time, it has gotten warmer, especially out here over the high plains region of New Mexico, Texas, over into the parts of the Texas Panhandle and Oklahoma. But much of the United States has warmed when you look at the differences in those two normal periods. Again, that's 1991 to 2020 minus 1981 to 2010. And if you look in the desert Southwest, obviously it's gotten much drier. And that's what we've sort of seen over the last few decades. Is this area, the semi-arid versus to arid area over here in the desert Southwest has started to expand a little bit over into the western parts of Oklahoma and the high plains. But remember, it doesn't matter even if you have increased a little bit, like up here in northwest Oklahoma, you can see if you subtract the two normal periods, it has gotten a little bit wetter. But when you get warmer, that does sort of eliminate that advantage of that increase of precipitation, because it does increase the evaporation. And also when it's warmer, at times you get those plants growing for longer, so that increases the transpiration as well. So even if you increase those precipitation amounts, it really depends on when those precipitation amounts fall, how quickly they fall, and how far apart between precipitation events they fall. So it's not always just the precipitation. Those temperatures do matter. And remember, we've also been getting these prevalent La Nina events over the last 20 to 30 years. So if you go back and you look, we see those big droughts of our past. They all tend to sort of get started or occur during those La Nina periods. So the 95, 96, 2000, 2001, 2005, 2006, the 2008 drought, 2010 through 2015 was started by one of the biggest La Nina events over the last 50 years. And then, of course, the 2017-18 was another La Nina event. And then this current drought started on the double dip the year of a La Nina event. So we had a La Nina event last year, and then we had one this year. So it's not just any sort of climate change going on. Of course, you can't remove the climate change from this aspect of drought. Droughts are expected to get worse and possibly more frequent. So you take your run-of-the-mill droughts, you add a little bit warmer conditions, a change in precipitation patterns, and you transform those droughts into more intense droughts. But also when you have more La Nina events working in conjunction with that, that's when you start to get more of these drought episodes that we see. And when they occur right perfectly timed with crop cycles like the winter wheat cycle, that's when you get some pretty disastrous results. So when we look at these La Nina events, we do see that they are expected to make this part of the country, especially the western parts of the state, a little bit drier than normal, a little bit warmer than normal. And that's exactly what we've seen over the last 20 to 25 years with these La Nina episodes. So this going through a little bit of our 2021-22 drought. The drought began really in August 2021. I mean, it's hard to pinpoint a true drought beginning. Intensified through the winter of 2022, really took off in December, as I showed you. That is not typical. It's not unheard of, but to see a flash drought situation like that is really not typical. The hottest December on record by over 5 degrees. April, May 2022, we have seen pretty good drought relief, especially across eastern Oklahoma. Things are compounded by the windiest March and April in the Mesnet era. So going back to 1994, you increase those wind speeds, especially across the western parts of the state. You get that enhanced evapotranspiration and soil erosion. Seen a lot of dust storms out there across the panhandles in western Oklahoma. And we've had a lot of wildfires too out across that region. So our final look is May has started off well above average temperature-wise, especially in western Oklahoma. So we do have to figure that in with any sort of drought intensification measurements that we make. So we got rainfall across far southwest Oklahoma last night. Temperatures have been 100 to 108 degrees over the last few days. So what's the trade-off there? What are the temperatures going to do to eliminate some of that moisture that fell? We'll just have to wait and see. And that's it for my presentation. Thank you.
Thank you very much, Gary. I'm going to now pass the presenter permission over to you, Victor. It'll just take me a few seconds. Did you get that? Oh, good, we can see that. All right, go ahead whenever you're ready. Victor, we cannot hear you if you're talking. You might want to check if you're muted.
Vic. Thank you, Joel. Let me back up here. Stand by for a second. Yeah, so my name is Victor Murphy. I'm the Climate Service Program Manager for National Weather Service Southern Region Headquarters. And Joel, thank you for, Gary, I'm sorry, thank you for the great setup. So I'm going to look a little bit here about the what the forecast shows going forward for Oklahoma, at least into the summer or through the summer months, and then we'll take a quick peek into the upcoming cooler season and see what that shows. Basically, so the mean annual distribution for Oklahoma varies greatly. You can see the eastern third of the state there gets 40 inches plus of precip per year. Parts of southeast Oklahoma actually see 50 inches plus, but things drop off dramatically or drastically there as you pretty much get west of I-35. You can see central Oklahoma, nice swath there of about 30 to 40 inches of precip. And then as you get into the western third of the state and the panhandle, things drop off quite dramatically. So big discrepancy, 70% of normal rainfall in the eastern third of the state is still going to be about 30 inches or so of precip, whereas in the western part of the state, it's be significantly less than that. Let's see here. Okay, so before I get started, I basically want to sort of break Oklahoma down into different climate divisions. In the climate world or the climatology world, we sort of break states down into climate divisions. And Oklahoma's got 9 different climate divisions. You can see them shown there. Each one's got a separate color. The panhandle is the light brown there. That's the climate division 1. And as you just work your way across, climate divisions 1, 2, 3, 4, 5, 6 across central, and 7, 8, 9 across the southern part of the state. You can see those are the various different mesonet sites, Oklahoma mesonet sites that are located there around the state. So let's do a quick breakdown of the percent of yearly precipitation by climate division over a 3-month period. So I have highlighted there AMJ here at the top center. It's April, May, June. And if you work your way down, it's July, August, September, JAS. So you can see this is percent of normal precip that falls during a 3-month period. So you can see the wet time of the year clearly for just about the entire plains, all the way from the Canadian border, actually almost down to Texas or so, is the period that starts in April, May, June, and sort of ends in July, August, September. So the common months here are pretty much April through June or April through July, perhaps. This is when the highest percentage of the yearly precip falls during these 3-month periods. You can see in the fall, August, September, October, through November, December, January, a fall into the winter, a lot of browns and reds here across Oklahoma, pretty much signifies a very small percentage of the yearly rainfall or yearly precip during that time period. And the same thing for the December, January, February through February, March, April. So, it's a very dry time of year anyhow, starting pretty much in September running through March or so. So as dry as it's been the last 6 months or so, at least across a lot of the state, or 7 months, and I agree with Gary 100% about the drought starting in August, especially in the northwest part of the state. And I'll take him at his word for August 21st. But that's exactly right. And the little area I showed here in the top right, you can see the heavier precip here that falls in the desert southwest during August, September, October. This is the southwest monsoon. You can see every climate division in New Mexico and Arizona gets a higher than normal percentage of their yearly precip during this time period. But you can see how that also bleeds over into into far western Texas and the Texas Panhandle, and actually even the Oklahoma Panhandle. So that's something I found very interesting. I mean, everyone thinks the southwest monsoon, everyone thinks, Arizona, New Mexico, etc. But I think the eastern extent of that actually does bleed over into far west Texas and the Panhandle in Oklahoma. And that southwest monsoon this year cut off really quick and really early in August, as Gary pointed out. And I think that's one reason why West Texas and the Texas Panhandle, Oklahoma Panhandle are so dry right now, or so bad off, because that summer monsoon should last beyond mid-August or so. So they got a head start on the drought, if you will, out there in West Texas or western parts of Oklahoma also, due to the sudden stopping of the southwest monsoon. So as I show here, the greatest months for precip, basically April through August. As I sort of talked about earlier, I show the same thing here. So it's that middle set of periods here, which are most significant. So breaking it down even further, so 6 of the 9 climate divisions in Oklahoma receive 35 to 40% of their yearly precip in the April, May, June time period. That'd be the middle color of dark there. 5 of the 9 see 35 to 40% in May, June, July. So what's the commonalities there? May and June. And lastly, the Panhandle is probably the one little outlier, perhaps, really, for the state as a whole. They see actually 45% of their yearly precip in the May, June, July time period. So anyway, bottom line is the one commonality is May and June. So Oklahoma's got a very distinct wet season, if you will, and that wet season pretty much confined to the 3-month period, April, May, June. You can always get outliers, a heavy rain event in October or something like that. But bottom line is, if you're going to avert or avoid long-term drought, you've got to get precip during that April, May, June time period. If you're in drought, you're going to see improvement. More likely than not, it's going to be in April, May, June. If you keep on getting your normal precip, every April, May, June, that alone will pretty much keep you out of drought. It'll also keep you relatively cooler in the summertime due to the increase in soil moisture. So I'm going to look at some of the quick climate divisions here. This is climate division 1, like I mentioned. This is the Panhandle. This is the Goodwell site, which Gary mentioned. I think it's in Texas County. It's the middle one of the 3 Panhandle counties. It's the middle one. You can see they get 45% of their yearly precip during the June, July, August time period. You can see the big spike up here in precip. It's a little bit later than the rest of the state. The rest of the state, as we'll see, it's a pretty big tilt towards May and June. But for the Panhandle, it's that southwest monsoonal influence. Basically, almost half the rainfall falls in the 3 months, June, July, August. So they haven't hit their wet season yet out here in the Panhandle. We'll see how the summer monsoon does for this year coming up. Like I said, last year it ended quick and it ended early. It just shut off on it like on a dime, as Gary said, August 21st or so out there. And it should last into September. You can see there's a pretty steep drop off here in September, but it does pick back up a little bit in October. Climate Division 2, which is north central Oklahoma along the Kansas border. This is very typical of the rest of the counties, or the rest of the state, rather. You can see this big peak here, May and June. About a third or 30% of the yearly precip falls in these 2 months. CD4 out in, I'm going to sort of focus on the central and western part of the state. Eastern Oklahoma is doing pretty well right now, so sort of skip over them a little bit. But anyway, CD4, which is the west central Oklahoma, borders the Texas Panhandle. Same thing there. I use Weatherford here. You can see how they get, 27% of their yearly precip May and June. Once again, big spike up from April into May and then into June. So this should be a wet time of year right now. You know, these 2 months right now, May and June. As Gary mentioned, we did have some nice improvement, over the last 30 days or so, starting in mid-April into maybe, the first week or so, first couple of days, I should say, of May. All right, Climate Division 5, this is Oak City area. Once again, you can see 8.7 inches falls in May and June. Once again, a disproportionate amount of the yearly precip falls in May and June. So as May and June go, to a large extent, that's going to be how, the yearly precip goes, or how, going into drought goes or getting out of drought goes. CD7, which is southwest Oklahoma, that's the extreme southwest portion. Same thing there, May and June, about 30% of the yearly precip falls in those 2 months. This is probably the hardest hit part of the state right now for drought. Although, as Gary mentioned, a few areas in Beckham County and Greer County and Harmon County actually had about an inch and a half of rainfall last night. Sorely needed. And then lastly, this is for Lawton, South Central Oklahoma, CD8. Covers Ardmore area and say Lawton. And once again, you can see May and June are the far and away the wettest 2 months. So, the screaming message here is you need precip in May and June to avert or avoid longer term drought. And as Gary said, I agree, this drought right now, as bad as it is still very short term in nature. It started maybe, mid to late August. So we're like in month 8 or so of it. So will this become a longer term drought? Will it last through the summer? And will it go into the latter part of the year? So as Gary showed, over the last 30 days or so, there's been some winners and losers as far as precip goes. This is through May 9th, so it does not include last night's rainfall. But you can see the wetness there in the eastern third of the state and the dryness in the western third of the state. A few fingers of competing dryness versus wetness there. And I do agree with Gary about the south central part of Oklahoma, say Carter County, down towards Love County, as far as being an area of concern, perhaps, for longer term drought. And this is from the measurement you can see over the last 30 days. You can see the winners really clearly. Some parts there in Weber Falls area, Haskell, in east central Oklahoma here had 15 inches plus of precip, whereas the measurement site out here in western Oklahoma had about 1/100th of that, which is 0.17. So, and a few sites out here in the western Oklahoma, southwest Oklahoma, actually may have picked up more rainfall last night they saw the last preceding 30 days. So good news out there from last night, but you can still see how certain parts of the state, were comparative losers when it comes to getting precip over the last 30 days. So what does the future hold going forward? Well, here's the 7-day forecast. This is valid from this morning. Folks, in general, I think you saw it, over the weekend. We've turned on a dime again. I mean, as wet as we were starting maybe mid-April, running to about maybe May 2nd or May 3rd or so, we flipped on a dime. Same thing down here in Texas. We were wet through like about May 3rd or so, Thursday, Friday, 4th and 5th of May. Some of our transition days, and all of a sudden, boom, the heat hit, on the weekend, May 7th through 9, all kinds of 100-degree temperatures across, western third of Oklahoma, across a lot of West Texas. And like I said, folks, we've turned on a dime. Here's the 7-day precip forecast. Pretty much less than 1/10 of an inch across almost all of Oklahoma. The wettest parts are actually a few areas out here in the Panhandle, might get some afternoon thunderstorms, but this is very dry, folks. This is the wettest time of the year. We should be seeing, on average, most of this area should be seeing about 1 inch of precip per week. And instead, we're going to get, probably near 0. So that's not good, not in the wettest time of the year. How about the week 2 forecast? Basically, this is from the Climate Prediction Center. You can see a 40 to 50% probability of below normal precip covers almost all of Oklahoma from May 18th through 24th. So that's week 2. Conversely, only about maybe a 15 to 25% chance of above normal precip. So odds are tilted sort of 2 to 1 or 3 to 1 for week 2 of being drier than normal, which once again, not good when it's your wettest time of the year. Here's the North American Ensemble forecast system. for week 2 as far as giving us some amounts goes. So average precip this time of year should be about 1 inch per week. So what's the probability of us seeing 1 inch of precip, for week 2, which is basically May 18 through 25? Well, you can see the odds are less than 50% everywhere. 50% line starts with the greens, and you can see, except for a little small sliver of extreme northeast Oklahoma, pretty much the entire state's got less than 50% probability of seeing 1 inch of precip in week 2. And that, once again, that's about the average, 1 inch or so. You can see out here in western Oklahoma, basically less than a 40% chance of seeing 1 inch plus of precip. So once again, we're staring at a higher risk of more dryness going into week 2. How about weeks 3 and 4? This forecast from CPC also was issued this last Friday, runs through June 3rd, runs into the first week of June. Once again, same thing. You see a tilt towards dryness, especially in the harder hit western part of Oklahoma, where there is enhanced chances, or more likely than not, a higher probability of drier than normal conditions. So we're going out through June 3rd, folks. That's about 3 weeks, 4 weeks or so from now. And everything we look at for that 4-week period is showing us, a signal for below normal precip. During the wettest time of the year, not good. And I'm glad I'm hoping the first one I mentioned, 2011. I think Gary already did that. But there is some cause for concern, or some similarities perhaps between this coming summer and 2011, perhaps. La Nina being one of them, and I'll talk about that a little bit later on. So how about going forward? Here's a May, June, July outlook for precipitation for Oklahoma. Once again, so this pretty much takes us through the July. Once again, you can see a strong tilt for dryness across most of the state, except for the eastern third, which, they were okay to begin with. So I think if you're in the eastern third of Oklahoma, you can probably, breathe a sigh of relief as far as drought goes, but certainly not the case for the western half of the state, and especially not the panhandle. Here's the summertime, June, July, August, going forward 1 month. And now you can see pretty much the entire state of Oklahoma has a tilt towards below normal precip. So it's not a very rosy picture going forward, unfortunately. Those who got the precip the last 30 days are blessed and very fortunate. But like I said, going forward, not a whole lot of good news, especially for the western half of the state. So the Climate Prediction Center, they have these called mega climate divisions, if you will, in which they break the state up in these relatively huge areas. This is how they make their long-term forecast. So I clicked on the one here for Central Oklahoma, and it's a probability of exceedance calculator. So the average precip, this is for the June, July, August time period, which covers the summertime. And for this relatively large climate division here, or area, which covers most of Oklahoma, at least the central and western part, you can see the average precip should be about 10.8 inches. Probability of exceeding that, 38%. So once again, tilt towards dryness. How about temperatures? Well, as you might expect, Oklahoma certainly fits in with the rest of the country. And you can see a very strong tilt here for warmer than normal temps this summer. Let me see the third color in here. This would be about a 50 to 60% probability of above normal temperatures here across most of Oklahoma, which would give you about a 7 to 15% chance perhaps of below normal temps. So 50 to 60% probability of above, about 1/3 chance of near normal, and then that leaves us about a 7 to 15% chance of being below normal. So odds are tilted to at least 3 to 1 or even 4 to 1 or more in favor of warmer than normal temperatures for this summer. Once again, not good. I did the same thing for the temperature probability for June, July, August, for this large climate division here. Once again, the average temperature for this area for June, July, August is 80.4. Probability of exceeding that, 70%. So looks like in general going forward for summertime for most of Oklahoma, probably about a 70% chance, and this seems reasonable, about a 70% chance of being warmer than normal. Only about a 40% chance or 38% chance, something like that, of being wetter than normal. So we're looking at, you know, the statistics here are showing us, as are the CPC forecast. So we're looking at more likely than not drier than normal and hotter than normal for the summer. How about going forward beyond that? Well, no good news here either. As Gary mentioned, we've had a couple La Nina events the last two cold seasons. Well, folks, it's looking more and more like we're about to have a triple dip La Nina, if you want to call it that. The probability right now is about 50%, maybe a little bit higher than that slightly, that will continue with these below normal temperatures in the equatorial Pacific Ocean, which in turn tends to keep the southern plains, Oklahoma and Texas both, drier than normal during the winter season. So we're probably, you know, with the odds of this triple dip La Nina increasing and probably slightly above 50% right now, looks like we'll probably have that triple dip, which will probably mean another relatively dry fall and winter going forward. So you can see right now, the map here on the left shows previous double dip La Ninas, if you will, when you've had two La Ninas in a row. Here's year one down here. Here's year two over here. And you can see most of the time you rebound. But here we are right now at the end of March. This is as cold. After 2 years of La Nina, we are actually as cold as we've ever been after a 2-year double dip. So you can see things also slightly starting to decrease. So this is actually sort of going into uncharted waters here as far as the strength of this third year La Nina goes. So unfortunately, that's another bit of bad news, you know, looking forward into the fall or into the winter time even. And this graph here is from our friends at NCEI. It shows the amount of precip needed to end drought condition in 2 months' time. And it's based on the PHDI, which is a Palmer Hydrologic Drought Index. It's really sort of skewed towards hydrology, which is always the last to improve during a drought. You know, you get wet, agriculture improves, risk of wildfires decreases, but a lot of times your stream flows and your river flows are the last ones to improve. Anyway, you can see here for Southwest Oklahoma, the climate division looks like 4 and 7 out here. You know, basically looking at about 15 inches plus precip needed in 2 months' time to go to D0 on the drought monitor based on the hydrologic scale. So, you know, right now this area is basically D3, D4. So how much precip will it take to get out of drought, or to get down to D0, if you will? And you can see those amounts. What's the probability of that happening? Well, for Central Oklahoma, the Climate Division, which includes Oak City, about a 28% chance of getting out of drought. This is in 4 months' time. So this would be through the end of, through Labor Day, say. You see Central Oklahoma's got the pretty good probability. They're about 28%. Eastern third of Oklahoma, once again, looks like they're pretty much out of the woods as far as any, you know, major drought is concerned, or drought issues are. But you can see the rest of the state, you know, basically the other climate divisions, 1 and 2, 4, 7 and 8, basically very, very low probabilities of getting out of the hydrologic drought over the next 4 months. That would be basically D0. D1 is considered moderate drought. D0 is just considered abnormally dry. It's not considered drought. The Panhandle, less than a 1% chance. Obviously, that's where the drought's been there the longest, most persistent, etc. Stands to reason they'd be the least likely to improve. In some summary, you know, except for the Panhandle, April through June, wettest time of the year, stands to reason that drought improvement, if it were to occur, would be during these months. So this is the time of year when, if you're in drought, you should be getting out of it. So we got about 6 to 8 weeks left for that magic, you know, May, June time period before it's over and done with, before the window sort of closes. Unfortunately, well, eastern through Oklahoma should stay okay, you know, through June or so as far as drought goes, with all that recent rainfall. What happens with the summer monsoon in June through August is going to be huge for the Panhandle. We'll have to see what happens there. And then, like I said, going forward, once we get into July, the odds for improvement will be very slim, very small. It's just not a wet time of year. And obviously, it's the hottest time of year. And then going forward beyond that, the probability or the odds of that triple dip La Nina will lessen, I think, our chances for recovery in the 2022 to 2023 cold season. That's all I have, and I'll toss it back to you, Joel, so you can maybe moderate some questions. And I do want to point out, these are, before I end, Joel, I'm sorry, the last three links here at the bottom are links to the NWS weather forecast offices that serve Oklahoma. Our weather forecast office at Amarillo covers the Panhandle, and Norman covers basically the western half of Oklahoma. And then our forecast office in Tulsa, TSA, is the eastern half. So you can click any of those, you can use any of those three links. It'll take you to their homepage for those individual forecast offices, depending upon where you live at. You can have all kinds of information there, and contact information, phone numbers, etc., if you have any specific questions for your area. And that's all I have, Joel. Thank you.
Awesome. Thank you, Victor. That was great. We do have some time for questions. If you have a question for either Gary or Victor, type them into the questions box and I'll read them and they can answer them. There was the first question that has come in. Gary has already typed the answer to the person who asked it, but I think for the benefit of everybody else who's attending, I might give Gary a chance to read that question and answer for the benefit of everybody. So the question is, when will the Oklahoma Mesonet start using the 91 to 2020 normals? And so, Gary, maybe you can explain what that is and what you're working on and why those normals are important.
Right. So we are, on some of our products, we're still in the 1981 through 2010 normals because the normals we needed, the gridded normals for some of our products, have just been released. So we're just now trying to incorporate those into our products. Some of our products do have the new normals. I think when we start to get into the looking at just how much those normals differ between 1981 and 2010 versus 1991 through 2020. When we're looking at those maps, the like percent of normal maps, the departure from normal maps, it still shows basically the areas in deficits, the areas in surplus. So there's not like a 5 to 6 inch difference in those maps to where all of a sudden we would be well above normal or well below normal in the difference in the map. So the maps are still basically good, even though the normals are outdated by one cycle. But they will change slightly whenever we get the new normals incorporated. But like I said, those gridded normals are what we needed, and they were just released. And so we'll start to get those incorporated as our computing folks start to put those in.
Great. Thanks for explaining that. Okay, my next question is for either or both of you. And you both mentioned an analogy of this year's drought with 2011 and what was happening there. I think for people like me who are new to the region, or for people also like me who just have shockingly bad memories, can you tell us the story of what happened in 2011? How did that start? How long did it last? And just help us remember sort of that history.
Right. So the 2010 to 2015 drought started basically about mid-fall in 2010. The deficit started then. 2011, early spring, things started to get really weird in the southern plains. Okay, so for Oklahoma, the western half of the state in April became very hot, very dry, mired behind seemingly endless dry lines. We were having temperatures already up in the upper 90s, a couple of hundreds here and there, winds of 50, 60 miles per hour, blowing dust every day. While on the eastern side of the state, they were getting 50 tornadoes, which was a record at that time. So just east of I-35, every single one of those 50 tornadoes on the east side of that dry line was to the east of I-35. So, and then it took off from there. Our temperature started going up dramatically throughout May and then through the summer, of course. May, we had a slew of hundreds. It looked a lot like our current number of 90s and 100s do now across western Oklahoma. That's what we ended up with in May of 2011. And then, of course, we ended up, Texas and Oklahoma tied for the hottest summer on record in the United States, based on statewide averages. So dating back to 1895 when the records began. So if you look at that June through August period, Texas and Oklahoma both tied for the warmest or the hottest summer on record across the United States. And Oklahoma, unfortunately, in July, set the record for the hottest month based on a statewide average in the United States history. So it was drastic heat, the extreme of the extremes. And then, of course, the drought took off from there. We oscillated between relief in shorter periods, but intensification in longer periods, all the way through the spring of 2015. Mid-May, we had that what was called the Godzilla El Nino setup, and we had the wettest month in Oklahoma history in May of 2015. That ended much of the drought across the state, and then we've just gone into more of a simpler, shorter droughty period as we've gone forward from that. But that 2010 through 2015 drought was the worst drought in the Southern Plains, arguably since the 1950s. So we don't like to see analogs to that 2011 period, because that was really when that drought kicked off. And the ecologic and the environmental damage done during that summer of 2011 still exists today. So it still sets us up for a quicker return to drought because of the damage done to the environment and the ecology of the state of Oklahoma at that time, unfortunately. So when you have that extreme of event that occurred, that really sets the stage for another decade or so as we go forward. So that's why we don't like to see those analogs. And Victor, if you want to add anything, feel free. But that's really that last big drought in a nutshell, and why we don't want to see 2011 mentioned with relation to this drought.
Well, yeah, sure, that sounds pretty miserable. Victor, do you have anything to add?
No, I think, Gary, you nailed it. But the big thing in 2011 was honestly, we're very dry, going in, as Gary said, the dryness started, and North Texas and a lot of Texas is pretty much in the same boat. It started in fall of 2010. The dryness lasted, into the wet months, May and June. May and June were very dry, much below normal precip wise. I think we've already seen more precip, at least most areas probably seen more precip already than we saw back in April and May of 2011. So in that regard, we're a little bit better off. But the rain just stopped, and this time of year, you get that drought feedback cycle. Dry soils heat up. No moisture, no clouds, heat up, and it's a feedback cycle. And the summertime of 2011 was just ungodly. I don't remember if Oklahoma beat Texas or Texas beat Oklahoma, Gary. I'll take your word that we tied. But you think about it, we've got 125, 127 years of monthly weather data, and both Texas and Oklahoma tied for the hottest summer ever on record anywhere in the United States. It was just ungodly. And with that kind of heat, we did get some precip going forward, like Gary said, but the rainfall would fall in short bursts. It was never anything sustained. It was just a short burst, which would just sort of wet the soil. Then it'd be dry again for 2 or 3 weeks. We'd go right back to where we were again. And it took, it took at least through 2012, at least in Texas, for things to improve. Parts even 2013, as Gary said, even into 2015 perhaps. The hydrologic improvements were really, really difficult to come by because the runoff was just very, very minimal. I think it's one of the things that, talking to hydrologists down here, one of the big amazing things they saw was just a complete lack of runoff after 2011. Into 2012, we get some decent rainfall. There's this literally zero runoff, or much below normal runoff that you would expect after seeing the amount of rain that we would see. So that really exacerbated the recovery. And I think that's due to the temperatures. And one thing, drought has changed. I mean, I agree with Gary that, it was the worst since the 50s. But if you look at the temperatures from the 1950s drought versus the drought of 2011-2012. We were quite a bit warmer this time around, which leads to more evaporation, more water loss, due to the heat. So that's a big kicker now in these droughts. Is you can't just compare rainfall. And Gary did a great job of pointing that out in his presentation. You can't just look at rainfall values to compare it to. Temperatures now are warmer, and that increases evaporation, et cetera.
Right. So 2015 was a big El Nino year. Do you need a big El Nino to end a drought like that?
That's a good question, Joel. I would say no, but it doesn't hurt. It helps load the dice, if you will, towards getting the improvement. We're in the same boat here in Texas in 2015. We had, I think wettest month ever on record, also things like that. So, in a lot of ways, Oklahoma and Texas are joined at the hip when it comes to weather and climate patterns.
Sure. Now we just have
So I mean, you don't necessarily need to have the El Nino, but like I said, Joel, it certainly doesn't hurt, because during El Nino, as I mentioned, during La Nina, usually the southern plains, including Oklahoma and Texas, were drier than normal in say October through March or so. We're drier than normal during La Nina. Conversely, during El Nino, we're wetter than normal. So it certainly doesn't hurt to have El Nino conditions around. But the odds for El Nino this coming cold season are just incredibly small, probably less than 5-6% or so.
Sure. So referring to 2011, Lee Crowley reminds us that it hit 113 in Tulsa around August 3rd, 2011. We also have another question related to ENSO, but it sort of not. So aside from the ENSO patterns, which is La Nina and El Nino, are there other global climate indices that have statistically significant effect on Oklahoma rainfall? I added the statistically significant, by the way. Thanks for that question. That's a really good one. Gary or Victor, are there other climate indices that you look at?
One thing I would say, and we're sort of seeing it now, something called Pacific Decadal Oscillation. It's basically atmospheric pattern across the Pacific Ocean. Needless to say, it has a pretty good correlation with La Nina. When the PDO is negative, the southern plains tends to be dry. And we were negative back in that 2011 through 2013 time period. Went positive for a period of time. No surprise, we got wetter. It has flipped to negative in the last year or two. That's not good. But in general, that just sort of promotes that kind of a pattern, basically promotes La Nina events. And so sort of a chicken or egg type thing, which one comes first. But
sure.
Seeing the PDO negative as we're seeing it right now, that's sort of a long-term decadal type oscillation, whereas La Nina sort of vary from year to year. That's why it's called the Pacific Decadal Oscillation. It tends to, once it's in place, it tends to last for about 10 plus years or so. And the drought years of the 30s and 50s are both also associated with a negative PDO.
Thanks, Victor. Gary, anything else you want to add about other climate indices?
Yeah, like Victor said, there are several. The PDO, there's also what's called the Atlantic Meridional Oscillation. So all these things work in differing ways, but when they line up, you can get really disastrous results. So the AMO has a positive, negative phase as well. They don't, of course, control our weather, but they influence it. So whenever we had that 2011-12 period, all those lined up and worked perfectly together. And the PDO was, of course, favorable to La Nina. So when they line up like that, they really do tend to influence our weather in a bad way. Now, sometimes they influence it in a good way. Like, for instance, the ENSO cycle can probably about a third of our weather can be explained by ENSO, and the rest, are differing other types of naturally varying factors. So, like Victor said, though, you don't want that PDO to be in this phase where you get the La Ninas, because it does lend you to extended periods of droughty weather.
Thanks to both of you. We're at the end of the hour, so I'm going to wrap things up there. My apologies to the last question that we did not get time to get to. I'll send you an email with a response to that. I'd like to thank all of you for joining us, and another big thank you to both Gary and Victor for coming along and sharing your expertise with us. We hope that you can join us next time we have a drought conversation like this. I'm not sure when that will be. Probably next time we're like, oh, we need a little bit more rain. Let's start talking more about drought. But that ends today's webinar. I hope you all have a great rest of your day.